June 6, 1944, 5:30 hours. Corporal Helmut Müller awoke to a sound that did not resemble battle, but tectonic rupture, as if the crust of the earth had torn open beneath his feet. His bunker, codename WN-72, part of the Atlantic Wall on Omaha Beach, vibrated like the rib cage of a dying machine. Steel beams groaned, dust rained from seams in the ceiling, the air itself felt heavy, vibrating under a pressure that came from nowhere and everywhere. He pressed his back to the 2-meter-thick wall. It was supposed to be unbreakable, supposed to be, according to the calculations of German engineers, each casemate could endure direct hits from the heaviest field artillery, then known even from the French, 155mm GPFs, or Soviet 203mm, B-4 seconds that had pounded European fronts for decades. Their math said the wall would hold, but mathematics, Müller realized, was no longer aligned with reality. The roar intensified, rolling, continuous, like the rhythm of a colossal forge. Every few seconds, a concussive wave pressed the air from his lungs. "This cannot be," he whispered, as if words could stop the physics unfolding around him. Through the narrow embrasure, he caught a glimpse of what no training manual had described. On the shoreline ahead, a neighboring pillbox, identical in design, same concrete thickness, same reinforcement grid, suddenly folded inward. A blinding white flash, a bloom of pulverized stone, and then nothing but a cratered void where a fortification had stood seconds earlier. The impossible had just occurred. A 406mm shell had struck it cleanly, bored through meters of concrete, and detonated inside. What remained was a hole filled with dust and disbelief. Müller stared, frozen. The impregnable Atlantic Wall, the fortress built to withstand centuries, was being dismantled in minutes. He could not know that what was destroying his world had begun a decade earlier, thousands of kilometers away, in the quiet design bureaus of American industry. There, engineers in grey coveralls had spent nights under the glow of fluorescent lamps, bending metallurgy, chemistry, and mathematics into something entirely new. They were not soldiers, yet their work would redefine war. At Westinghouse and Watervliet, in steel mills at Pittsburgh and laboratories at DuPont, equations turned into barrels, alloys into thunder. The Americans were not building for glory, they were building for precision, for repeatability, for scale. While Germany poured concrete, America refined steel. While one empire worshipped the wall, the other perfected the shell. The result of that asymmetry was now echoing across Normandy. From offshore, the USS Nevada fired another broadside. 3 barrels released 3 projectiles, each weighing over a ton, accelerating to nearly 800 meters per second, faster than sound, heavier than belief. Flight time, 43 seconds. Impact, annihilation. The Germans had built bunkers. The Americans had built mathematics that could kill bunkers. As Müller's bunker shuddered again, the overhead lights flickered and went out. Somewhere to the left, a man screamed, or maybe it was the concrete itself breaking. The sound was identical. For 3 years, the Atlantic Wall had consumed 16 million cubic meters of concrete and over 1 million tons of steel. It was meant to be a monument of endurance, yet within the span of a single morning, its purpose was reversed, from symbol of defense to exhibit of technological obsolescence. Above ground, the dawn over Normandy was hidden by smoke and dust. Ships on the horizon kept firing with mechanical rhythm, not rage but process. Each shell followed a trajectory calculated down to the meter. Each detonation was an equation resolved. Inside WN-72, the air was thick with cement powder and disbelief. Müller pressed his palm against the cracked wall. The surface was warm. The bunker itself seemed to breathe, expanding, contracting, as if its final heartbeat approached. When the next impact came, he did not brace. He simply looked at the ceiling and whispered something only the concrete could hear. Outside, the Atlantic Wall continued to dissolve under the precision of American guns, and with it the last illusion that concrete could defy intellect. To understand why Müller's world collapsed that morning, one must return to a different kind of battlefield, the engineering offices and industrial foundries, where 2 civilizations defined how they believed war should be fought. In 1940, when Hitler ordered the construction of the Atlantic Wall, German engineers carried the pride of a century of fortification science. Their lineage stretched from Vauban to Verdun. The trauma of the First World War had taught them that survival meant concrete, geometry, and endurance. The Atlantic Wall was not just a line of defense, it was an ideology of permanence. From Norway to the Spanish border, under the coordination of organization Tot led by Fritz Tot himself, millions of conscripted workers, French, Dutch, Belgian, German, poured concrete into dunes, cliffs, and ports. The numbers spoke of faith disguised as calculation. 15,000 concrete fortifications, 17 million cubic meters of reinforced stone, 1.2 million tons of steel, each structure tested, certified, and sealed with a sense of industrial invulnerability. To the German High Command, this was engineering as prophecy. The wall would outlast weather, time, and the tides of war. In military reports, its planners used a recurring phrase, unzerstörbar, indestructible. Every component was designed as if nature itself would attack it. Walls 2 to 3 meters thick, made from B350 grade concrete, reinforced with 32 mm steel rods spaced precisely 15 centimeters apart. Formulas controlled the mixture: high-grade Portland cement, granite aggregate, river sand, and chemical additives for density and waterproofing. Even the curing process was ritualized, temperature and humidity monitored by precision thermometers, each batch logged by serial code. To the German engineer, perfection of process was equal to immortality of outcome. The logic was seductive. If physics could be contained, war could be controlled. That belief, the fusion of rationality and arrogance, was the foundation of the Atlantic Wall. But across the ocean, a different philosophy was being forged, one that would eventually turn German certainty into ash. In American factories and laboratories, engineers were not designing for eternity. They were designing for iteration. Where German thought pursued the absolute, American thought pursued the adaptable. Theirs was not a wall to resist force, but a system to amplify it. By 1939, Westinghouse, DuPont, and the Watervliet arsenal had become crucibles of a new doctrine: industrial dynamism. While Europe was digging into soil and cement, the United States was rewriting the logic of artillery from the inside out: metallurgy, recoil absorption, and explosive chemistry. At the core stood the 155 mm M1 howitzer, later nicknamed Long Tom. It was not born from military tradition but from engineering obsession. Every element of its design, from the 45 caliber barrel to its hydropneumatic recoil system, represented the union of mathematics and mass production. The gun's muzzle velocity of 853 meters per second nearly doubled that of the average German howitzer. Its steel, heat-treated at Pittsburgh mills, endured pressures exceeding 3,200 atmospheres, about 40% higher than its European counterparts. The Americans treated each weapon not as craftsmanship, but as data: measurable, reproducible, scalable. The result was a gun that could reach targets beyond 23 kilometers, with accuracy unheard of in field artillery. But the true revolution was not in range. It was in consistency. A German artillery crew had to re-aim after every shot. An American battery could fire repeatedly, rhythmically, precisely as if connected to a single mechanical pulse. And behind every gun was not a craftsman, but a system. Industrial logistics, automated quality control, and chemical laboratories working in unison. The German faith in material permanence, concrete, steel, thickness, now faced an enemy that believed in intellectual mobility. Where Germany built a wall, America built a process that could evolve faster than any wall could harden. By 1943, the impact of this divergence became undeniable. Reports from the Italian front reached Berlin with disturbing implications. Bunkers on the Gustav Line, constructed with the same standards as those in France, were being punctured by 155 mm shells from American batteries firing 15 kilometers away. Field reports described holes through concrete 2 meters thick. Some officers refused to believe them, calling them exaggerations born of fatigue. But engineers examining the ruins found unmistakable evidence: deep, narrow craters, internal explosions, and overpressure, collapse signatures of delayed detonation shells designed to enter before destroying. The source of this devastation lay in another American innovation, Composition B, an explosive compound born at DuPont Laboratories. A precise blend of 60% RDX and 40% TNT, it delivered 50% more energy than standard German explosives and detonated at nearly 8,750 meters per second. Where German shells shattered surfaces, American shells penetrated and unraveled interiors. To the Americans, destruction was a problem of physics, not fury. To the Germans, resistance remained a matter of faith. The difference was fatal. In early 1944, Luftwaffe intelligence intercepted fragments of Allied communications mentioning bunker-busting rounds. Major Ottman examined impact sites in Italy and noted in his report, "The enemy possesses artillery of unknown power. Their shells exceed our expectations by a factor of 2 to 3. The phrase, unknown power, was not metaphor, it was literal. The Reich's fortification data had no field for what America had built. Yet, in Berlin, skepticism persisted. The Atlantic Wall was considered unbreachable by any weapon short of naval guns of the heaviest caliber. Field Marshal Erwin Rommel, inspecting defenses in February 1944, told his officers, "They may fire as long as they wish. Our bunkers will stand for 1,000 years." Those words would echo in bitter irony 4 months later, under the smoke of Omaha Beach. The truth was already written, not in concrete, but in chemistry, in metallurgy, and in an industrial rhythm that Germany could neither match nor anticipate. The Atlantic Wall was not about stone versus shell. It was about two civilizations expressing two opposing philosophies of war. One believed safety lay in endurance. The other believed victory lay in evolution. And evolution had already chosen its side. By late 1943, the contradiction between German confidence and American advancement was no longer theoretical, it was measured in fragments of shattered fortifications. On the Italian front, at Monte Cassino and Anzio, reality began to dismantle doctrine. Lieutenant Colonel Karl Steiner of the 76th Engineer Battalion, a veteran of Verdun and Stalingrad, commanded a defensive sector built to German standards, 1.8 meters of reinforced concrete, double-layered roof, and steel shutters for every embrasure. The kind of structure textbooks described as resistant to all known field artillery. On November 12, 1943, American 155mm M1 howitzers began to fire. The first shells landed with the deep concussion typical of heavy ordnance, but the aftershock was not what Steiner expected. His bunker did not shudder from the outside. It cracked from within. The shell had penetrated the front wall, exploded in the central chamber, and vaporized everything inside. In his diary that night, Steiner wrote, "I have seen the French guns at Verdun. I have lived through the Soviet barrages at Stalingrad. But this defies any framework of reason." That entry became a quiet obituary for a century of fortification theory. The pattern repeated itself across Italy. At Anzio, in January 1944, a 240mm American howitzer shell pierced the command bunker of the German 14th Army, 3 reinforced floors deep, and detonated in the basement, erasing the entire staff. For the first time, German field commanders saw that mathematical safety margins no longer existed. General Heinrich von Vietinghoff, commander of the 10th Army, sent an urgent telegram to Berlin. "Enemy artillery demonstrates penetration power significantly beyond calculation. Fortification standards must be revised immediately." At the Oberkommando der Wehrmacht, OKW, the report was quietly dismissed. Some senior officers labeled it emotional exaggeration. Others simply didn't believe that a 155mm shell could outperform their 210mm siege mortars. But the evidence was mounting. Crater analysis showed penetration depths of 1.8 to 2.2 meters, far exceeding theoretical limits. Fragments of shell casings revealed alloys unfamiliar to German metallurgists, heat-treated, stress-resistant, and refined to microscopic precision. Every new report suggested the same conclusion. The Americans were not just firing shells, they were firing the future. Meanwhile, Allied factories moved at a rhythm Germany could no longer imitate. At the DuPont lines in Delaware, machines assembled 15,000 artillery shells per day, each filled with Composition B, and fitted with the new M51 fuse, a dual-mode device capable of either instant or delayed detonation. The same design allowed a shell to burrow through concrete before exploding inside, transforming bunkers into pressure chambers. On the front lines, this meant that German troops no longer faced bombardment, they faced implosion. By early 1944, Allied spotters reported entire sections of the Gustav Line flattened. Aerial reconnaissance showed something unprecedented. German bunkers destroyed not by repeated impact, but by single, precise hits. Major Otto Mann of the Luftwaffe's Engineering Corps personally examined several such sites. His conclusion was stark. The destruction produced by these shells exceeds expectations by a factor of 2 to 3. This is a new class of artillery. But the most telling evidence came not from laboratories, but from the silence of the men who had once believed in concrete. In February 1944, during Rommel's inspection tour of the Atlantic defenses, junior engineers began to whisper doubts. If American guns in Italy could pierce bunkers 2 meters thick, what would happen when those guns arrived in France? Rommel dismissed their anxiety. He had faith in numbers, in thickness, in the very idea of immovable defense. He repeated the same sentence to reassure them. They can shoot as long as they like. Our bunkers will stand for 1,000 years. The phrase became the incantation of denial. Across the Channel, American and British analysts were mapping every fortress along the French coast. The resistance had supplied blueprints, wall thicknesses, and ventilation layouts. In underground labs, American ballistic engineers plotted trajectories to exploit weak points, the thinner rear walls, the roof joints, the embrasure seams. War was becoming not a contest of armies, but of architectural mathematics, and the Atlantic Wall, built to resist brute force, would now be tested by precision it had never imagined. By spring of 1944, the contradiction had matured into certainty. The Germans still believed in the wall. The Americans had already built the weapon that would erase it. The stage was set not for a battle of courage, but for an industrial experiment conducted on a continental scale. On June 6, that experiment began. When the first 406mm naval shells from the USS Nevada struck Omaha Beach, the Atlantic Wall didn't crumble because of firepower alone. It crumbled because it was designed for a world that no longer existed. The collapse of the Atlantic Wall was not a miracle of firepower. It was the inevitable result of an industrial system that had learned to calculate destruction like a production process. To the German soldiers sealed inside their bunkers, the bombardment felt divine, incomprehensible, almost supernatural. But to the men who built it, the American engineers, chemists, and metallurgists, it was nothing more than physics executed at scale. At the center of this system stood a single machine, the 155mm M1 howitzer, the weapon that transformed mathematics into dominance. Its 45 caliber barrel, nearly 7 meters long, expelled each round at 853 meters per second, a speed that blurred sound into shockwave. The hydropneumatic recoil system, a fluid-filled skeleton of steel and nitrogen, absorbed the entire force of the explosion and reset the barrel instantly, allowing a continuous rhythm of fire. German gunners still had to re-aim after every shot. American batteries fired as if controlled by a single heartbeat. The secret was not in the barrel, but in the steel that shaped it. At Pittsburgh's Crucible and Carnegie Mills, furnaces burned night and day, their heat regulated by precision thermometers that never varied by more than half a degree. Each barrel was quenched, tempered, X-rayed for microfractures, then measured again. No part of the process relied on guesswork. Every gun left the line identical to the one before it. Where German craftsmanship celebrated the hand of the master, American industry celebrated the absence of it. That uniformity was the real weapon. A system that could reproduce precision endlessly, the industrialization of accuracy itself. The shell completed the design. Germany's munitions relied on TNT, predictable, traditional, and safe. But the Americans had turned chemistry into geometry. At DuPont Laboratories, in a sequence of reactions hidden from both enemy spies and many allies, scientists created Composition B, 60% RDX, 40% TNT. It detonated at nearly 8,750 meters per second, 50% more energetic than conventional explosives. The material was compact, stable, and terrifyingly efficient. When ignited inside a shell's steel body, it didn't simply burst outward, it carved space apart. And then came the fuse, a small device that redefined purpose. The M51, adjustable for delay or instant detonation, allowed the shell to burrow through solid concrete before exploding inside. The effect was grotesquely precise. Walls that were supposed to repel impact instead trapped the blast within, turning bunkers into pressure chambers. In 1943, at the Aberdeen Proving Ground, observers watched a 155mm M1 round travel 15 kilometers and pierce 1.8 meters of reinforced concrete. The test of the larger 240mm shell pushed that to 3.5 meters. It was no longer artillery. It was engineering with a conscience removed. While Germany trusted fortitude, America trusted throughput. The wall had taken 3 years to build. The guns that destroyed it could be replaced every month. Pittsburgh's Westinghouse factory operated in a constant cycle. 3 shifts, 7 days a week. 12 howitzers completed each week, each one tested at full recoil, maximum pressure, and extreme temperature. A single defective part could halt the line not for discipline, but for data. Errors were analyzed, converted into formulas, and reinserted into the next batch. Every flaw made the system stronger. In Delaware, DuPont's lines produced 15,000 shells a day. Machines filled, sealed, and stamped them with mechanical indifference. X-ray imaging checked for cavities invisible to the eye. The rejection rate was below 0.3%. Across the ocean, German factories bombed, short on alloys, manned by forced labor produced ammunition with 15 to 20% defects. In America, the weapon was not the gun or the shell. It was the feedback loop. Research fed production. Production fed analysis. Analysis created improvement. Each cycle refined the system's precision, shrinking the distance between invention and deployment to months. The result was a machine that learned faster than its enemy could adapt. Behind the battlefield, gunners stood another army unseen, scientific, and exact. From the laboratories of Johns Hopkins and MIT to the Ballistic Research Center at Fort Monroe, mathematicians built firing tables that accounted for every variable: humidity, wind speed, powder temperature, even the erosion inside the barrel after prolonged use. The act of firing became a calculation. The Mark 8 radar system on American battleships could detect coastal targets within 10 meters of accuracy, even through fog or rain. Radar proximity fuses turned anti-air and artillery shells into intelligent instruments, detonating in the air above targets rather than on the ground. Each fragment fell at calculated velocity. Each explosion had a reason. When the USS Nevada opened fire off Normandy, it was not groping for targets. It was executing a sequence pre-solved by engineers months before. The Allied fleet carried not just guns, but an algorithm. Precision had replaced chance. By June 6, 1944, every German bunker along the coast existed inside that equation. The French resistance had supplied blueprints, ventilation maps, and wall thicknesses. British intelligence had converted them into ballistic coordinates. The Americans had assigned each target a firing solution and a fuse type. The thickest walls faced the sea, but the sea was not the target. The thinner rear partitions, the roof seams, and the communication conduits were. When the shells arrived, they didn't batter defenses, they dissected them. At WN-71, a 406mm naval shell from USS Nevada pierced the front wall of a casemate, detonated inside, and produced a pressure of 50 atmospheres, enough to vaporize human lungs without leaving external wounds. At Point du Hoc, a 240mm shell punched through 3 levels of concrete, then exploded in the basement, folding the entire structure inward like a collapsing lung. By 6:45, sections of the wall were gone. By Sept 15, communications failed. By 8, silence replaced strategy. The Atlantic Wall, the symbol of Germany's belief in endurance, was being erased by the logic of iteration. While the Reich depended on fixed structures, the United States built a machine that moved, adjusted, and replenished itself without pause. In 1944 alone, American factories produced over 17,000 heavy artillery systems and more than 24 million shells. Every week, Liberty ships left East Coast harbors carrying 10,000 rounds apiece, crossing the Atlantic faster than German logistics could replace losses. Patton would later call it the iron heartbeat of victory. He was right. The battlefield was only the surface. The true front line lay in the assembly lines of Pittsburgh, in the chemical vats of Delaware, in the endless rhythm of machines that did not rest. The Germans believed they were fighting men. In truth, they were fighting a process, one that turned data into detonation. When the shells landed on Normandy, they carried more than explosives. They carried the weight of a civilization that had mastered synchronization between science and steel, between thought and manufacture. And with every impact, the Atlantic Wall learned the same truth repeated across history. Those who build for eternity are always destroyed by those who build for change. The walls cracked, the bunkers folded, the faith in permanence shattered, and the system kept firing cold, precise, unfeeling, until there was nothing left to prove. Because in that moment, the machine had already spoken. Your concrete cannot stop thought. June 6, 1944, 5:50 hours. The English Channel was a sheet of smoke, trembling under a sound that didn't belong to the world of men. 864 Allied guns fired in unison, each barrel part of a greater rhythm. It was not chaos. It was synchronization, the sound of an industrial civilization expressing itself through mathematics and fire. Inside the German bunkers, it began as vibration. Dust fell like snow. Air turned into something heavier, a force that pressed against the chest. At WN 72, Corporal Helmut Müller felt the concrete breathe expanding and contracting like a living thing under unbearable pressure. Somewhere above, something collapsed. The light bulbs shattered. The Atlantic Wall was beginning to break not because it was weak, but because it was built for another age. The first fortification to die was the Merville Battery. USS Nevada's 406mm guns fired 3 rounds. The first shell struck the embrasure and penetrated 2 meters of concrete before exploding inside, generating a shockwave that liquefied everything in the chamber. The second hit the roof, igniting the ammunition depot. The third tore through the thickest wall, 2.5 meters of B350 grade concrete, leaving a hole wide enough to walk through. 3 years of labor, 3 shots. By 6:30, HMS Belfast and HMS Diadem had joined the symphony. Their 152mm shells, fitted with delayed fuses, detonated deep inside the bunkers at Gold Beach. A German officer later wrote, "The wall held for a heartbeat, then the inside exploded." It was a new category of death destruction from within. At 7:15, the radio operator at Point du Hoc transmitted one final message. Casemate breached, half garrison gone, no communication. Then, silence. By 7:30, destroyers closed to within 3 kilometers of the shore. Their 127mm guns, small compared to the battleships, now fired with surgical precision. Observation posts, rangefinders, and field headquarters vanished in sequence. Each explosion corresponded to a coordinate. Each coordinate had been calculated months earlier. In 40 minutes, 31 of 47 strong points in the Omaha sector were erased. 3 years of calculation undone by a better one. The men inside those bunkers were not defeated, they were outcomputed. In Berlin, the reports arrived broken and contradictory. Major General Wilhelm Fechter, one of the Atlantic Wall's chief engineers, stared at the first confirmed message. Bunker WN 74 destroyed. Wall thickness 3.2 meters. Direct penetration. He said nothing. He had personally supervised its design, its curing times, its steel reinforcement spacing. He had seen 210mm mortars bounce off similar structures without leaving a mark. Now, in one morning, the entire discipline of fortification engineering was dissolving. They must be using naval guns, he murmured. He was right, and yet even the smaller guns, the 155 seconds and 240 seconds, were achieving the same results. The laws of warfare had changed without warning. At 8, Field Marshal Rommel was away from the coast, confident that his wall would hold. He believed in fortitude in thickness, in endurance, in the logic of the static. But by 9, radio silence spread across every command channel. The Atlantic Wall, meant to be a self-sustaining system, had ceased to exist as a system at all. In the underground command post of the 352nd Infantry Division, Crace screamed into the phone lines, demanding answers from positions that no longer existed. The air stank of burning insulation. Aide-de-camps ran through corridors choked with dust and disbelief. Someone whispered, "WN-75 is gone." Crace refused to hear it. "Impossible!" he shouted. But the impossibility was happening, one coordinate at a time. Outside, the wall was dying as it was meant to live systematically. For the men who survived, the greater destruction wasn't physical. It was psychological. The Germans had believed in concrete as the last sanctuary, the embodiment of control over chaos. When the shells began to penetrate that illusion, something deeper cracked. Letters from the front capture the moment that belief ended. One grenadier wrote, "Even underground, the walls breathe before they fall." Another, "They shoot from beyond the horizon. Their shells find us as if they can see." The idea that concrete could save them, that material could outlast intellect, died faster than the structures themselves. By mid-morning, those still alive crawled out through the smoke, dazed, silent, carrying nothing but the weight of a realization. The war they were fighting no longer existed. Back in Berlin, Alfred Jodl convened an emergency session at the Reich Chancellery. Physicists, metallurgists, and ordnance experts crowded into the conference room. Professor Walter Dornberger, father of the V2 program, spoke first. "The Americans have achieved a breakthrough we never suspected. Their artillery parameters exceed ours by a factor of 2 to 3. Colonel Georg Bruchmüller, son of the legendary World War I artilleryman, presented fragments from Normandy. "These are not mere shells," he said. "They are mechanisms of logic. Every layer, every alloy, every fuse has a purpose. They are designed to think before they detonate." He displayed crater measurements. A standard German 155mm shell left a crater 1.5 meters deep. The American equivalent, filled with composition B, left a crater twice as large. "It's not just more explosive," Bruchmüller said quietly. "It's a new way of transmitting energy." Professor Ernst Sachs summarized the meeting in one sentence. "We are fighting a nation that has industrialized precision itself." Jodl's response was short. "We have lost the technological war." No one contradicted him. The silence that followed was the sound of empire meeting arithmetic. Back in Normandy, by noon, the bombardment had become a steady pulse. The wall that was meant to endure centuries had lasted 4 hours. German soldiers who emerged from the ruins did not fight. They stared at the horizon, the line where fire met water, as if staring at the end of an era. SS officer Klaus Bergmann of the 12th Panzer Division wrote later from captivity, "I fought in Kursk and Kharkov. I saw Soviet artillery erase entire districts, but never this. The air itself killed us. The Atlantic Wall was not conquered. It was rendered irrelevant. Its destruction was not the collapse of a structure. It was the moment a civilization realized it had fallen behind its own invention. By 1430, the counterattack units arrived too late. They found no battlefield, only a wasteland of twisted steel and pulverized stone. The silence was heavier than the smoke. They understood, without orders or words, that the age of fortresses had ended. What had once been the ultimate expression of human control, the bunker, the wall, the impregnable structure, had become a tomb for the very idea of permanence. In that single morning, the Atlantic Wall fell, and with it, the belief that matter could ever outthink the mind that built it. The morning of June 6th did not just mark a military collapse. It marked a philosophical one. For centuries, war had been defined by endurance, the thicker wall, the deeper trench, the heavier armor. But at Normandy, the equation inverted. Power no longer belonged to those who could withstand impact, but to those who could design impact itself. What the Americans demonstrated was not merely superiority in guns or explosives. It was systemic intelligence, the synchronization of science, production, and logistics into one coherent organism. The battlefield was only the final manifestation of a chain that began in laboratories, passed through assembly lines, and culminated in mathematics. Germany had mastery in engineering, but it was a mastery trapped in isolation, each discipline working in prideful independence. America had something different: integration. Metallurgists, chemists, physicists, and logisticians shared the same table. Equations moved directly from research papers to the factory floor. The distance between theory and practice was shorter than the range of their guns. That integration created a self-reinforcing cycle. Science produced discovery. Industry transformed discovery into production. War refined production into doctrine. The result was a civilization that no longer fought battles, it executed processes. This was the true revolution of the industrial age. The shell that pierced the Atlantic Wall was not just a piece of steel, it was the physical embodiment of a thought system that valued adaptation over permanence. Each gun, each fuse, each chemical compound carried within it the belief that progress must never rest. Germany, in contrast, built its fortifications as monuments. America built its weapons as iterations. That single difference decided the fate of the wall, and, by extension, the war itself. The lesson of the Atlantic Wall was not military. It was existential. When faith in concrete replaced faith in innovation, the outcome was inevitable. The German engineers believed their equations were eternal, that a 2-meter wall of reinforced concrete could resist any future projectile. But the Americans had already moved into the future. They had replaced prophecy with production. What collapsed at Normandy was more than a line of defense. It was the last illusion that material could outlast intellect. Even within the German command, this realization began to sink in. Professor Ernst Sachs wrote privately in late 1944, "Our defeat lies not in courage or leadership, but in the slowness of thought. We have tried to defend the present against the future." That sentence might as well have been the epitaph for the Atlantic Wall. In the months that followed, the same logic of annihilation repeated itself. At Anzio, in the Ardennes, at the Rhine, the pattern was identical. Structures crushed not by numbers, but by calculation. American artillery did not merely aim at targets, it aimed at vulnerabilities, the thin walls, the ventilation shafts, the joints between slabs. Each strike was informed, specific, and final. Intelligence and fire were now one system. And yet, beneath the triumph of precision, there was a darker truth. The same intellect that could dismantle a fortress from 30 kilometers away could dismantle a city just as easily. The fusion of science and industry had given humanity a new power, and with it, a new moral vacuum. The Atlantic Wall's destruction proved that human beings could perfect the art of breaking things faster than they could perfect the art of understanding them. From that moment onward, war would never again be fought by men alone. It would be fought by systems, factories, laboratories, logistics chains. These became the real front lines. Soldiers were no longer the instruments of war, they were its byproducts. For the Americans, the victory at Normandy confirmed a new doctrine, that technological acceleration itself was a weapon. To stay ahead was to survive. To pause was to perish. The Atlantic Wall had been designed to endure a century. It did not survive a morning. And so the new lesson emerged, one that outlasted the war itself. No wall is eternal. No structure, no ideology, no empire can withstand the velocity of innovation once it begins. In this sense, the Atlantic Wall was not destroyed by shells, but by time. Each American projectile was a fragment of the future striking the past. That is the industrial philosophy of the 20th century and its warning for the 21st. The machines we build to protect us inevitably become the symbols of our limitation. Concrete cracks, steel fatigues. But ideas evolve. The true power of a civilization lies not in the thickness of its walls, but in the speed at which it can rethink them. At the end of the day, as the smoke cleared over Normandy and the shattered bunkers cooled in the ocean wind, the truth was simple and irreversible. The Atlantic Wall was never defeated by strength. It was undone by intellect. And in that undoing, the modern world was born. By the evening of June 6th, the roar had faded. The beach was a scar of smoke, craters, and twisted rebar. The Atlantic Wall, once the physical embodiment of German certainty, now lay scattered in fragments across the sand. To the soldiers walking among the ruins, the silence felt unnatural. The air smelled of lime and iron, the chemical odor of pulverized stone. Concrete dust drifted over the surf like grey mist, and beneath it all, a deeper silence, the kind that follows when an entire idea has died. What had begun as a line on a map ended as rubble beneath the tide. Helmut Müller, one of the few survivors of WN-72, stood among the wreckage of his bunker. The structure that had promised invincibility now resembled a broken organ, chambers ripped open, cables hanging like veins. He ran his hand along what was left of the wall. The surface, once cold and hard, was warm to the touch, as if the concrete itself remembered the fire that had unmade it. The wall had not been defeated, it had been outgrown. In Berlin, months later, the phrase Atlantic Wall was rarely spoken aloud. It had become a ghost in the vocabulary of the Reich, a reminder that the past cannot be engineered to protect the future. What remained instead was the echo, the understanding that in the industrial age, every fortress carries the seed of its own irrelevance. The very technologies meant to defend a civilization eventually become the tools that expose its weakness. That is the logic of machines. They do not believe in permanence, they evolve, and they force their creators to evolve or vanish. In the years that followed, engineers across the world studied the ruins of Normandy not as monuments, but as data. They measured penetration craters, studied fracture lines, analyzed concrete compositions. What they found was not simply failure, it was transition. The Atlantic Wall represented the end of an era when defense was measured in meters of thickness. From that point onward, defense would be measured in time in the ability to adapt before the next revolution arrived. Artillery gave way to missiles. Missiles gave way to algorithms. Each generation of technology erased the assumptions of the last, moving faster than politics, faster than belief. And through it all, the same question whispered beneath every innovation. What happens when the machine begins to think faster than the civilization that built it? The lesson of Normandy is not about war, but about civilization itself. It tells us that progress is a form of erosion that everything solid eventually yields to thought. Concrete, armor, ideology, none can resist the acceleration of intellect once it takes form in industry. The Germans believed that physics would protect them. The Americans proved that physics could be redesigned. That is the true meaning of the Atlantic Wall. It was not destroyed by gunfire, but by evolution. And in that sense, the story never ended. Every data center, every missile silo, every nuclear shelter built since then is a descendant of that same illusion, the belief that permanence can be engineered. But the sea keeps rising, the machines keep learning, and history keeps repeating its one law. Those who build for eternity are always defeated by those who build for tomorrow. As night fell over Normandy, the waves erased the footprints on the sand. The wind moved through the shattered bunkers, producing a low, hollow resonance, a sound like breathing through metal. It was the echo of the machine, and it was still speaking. No wall lasts forever.